Zai, a very good morning to each and every individual. Now, today's topic we will be discussing about a mean of combined distribution. So over here, we are not just talking about mean of any distribution. We're talking about combined distribution. Now, mean in simple language, we know it also means average. Now, what do we mean by combined distribution? Now, let's say, for example, we have, let's say, supposing if there is only one set of, let's say, observations, then what we'd have to do, if I want to find the mean of this, what we do, we just add all of them, you add them, and then divided by how many observations are there, like 1, 2, 3, 4, 5, 6, 7, 8. So whatever is the total, we divide it by 8 and we get the mean. Similarly, if I want to find the mean of this, then what we do, again, we add them up, we get the total divided by how many numbers are there, how many observations are there. But now if I want to find the mean of the combined observation, like I have two sets of observation, like I have the first set of observation and I have the second set of observation. And if I want to find the mean of such observations or such combined distribution, then what we have to do is we just have a formula which we can apply to get the answer. So over here, x bar stands for the average or the mean of the combined distribution. Now the formula is n1 x1 bar, and bar means indirectly mean, plus n2 x2 bar divided by n1 plus n2, where n1 means a number of observations of the first distribution. Like for example, let's say for example, if it's this, okay, then how many observations do I have of the first? We have 8. So n1 over here becomes 8. Okay, n2 is the number of observations of the second distribution. So the second distribution is this. It's not necessary that they have to be the same number of observations. We can have a little more, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So over here n is equal to 10. So over here we call this set of observations as n2, and over here we call it as n1. So that is the meaning of n1 and n2. How many observations do we have over here? How many observations do we have over here? And x1 bar is the mean of the first distribution. So over here, what we do is we separately go ahead and find the mean of this one, and whatever answer we get, we call that as x1 bar. Similarly, we find the mean of this one, and how do I find the mean? Total divided by the number of observations, and we call that as x2 bar. So over here, x1 bar means the mean of the first set of distribution, and this x2 bar is the mean of the second distribution. Okay, but usually what will happen is you don't have to worry about all these kind of questions, because usually n1 is directly given to you in the question, x1 bar is also given to you in the question, so they will directly give you these kind of values. You just have to make sure that you identify them correctly. For example, okay, let's say for example we have this question. It says there are 60 students, so we have a total of 60 students in a class, of which 25 are girls. If 25 are girls, it's obvious that the remaining has to be boys, so we know that there are 35 boys. But over here the question already has mentioned that the average weight, that means the mean weight of 25, how many girls are there? There are 25 girls, so we can say, so this is the first set, so we'll say n1 to be as 25, because we have 25 girls, will call them to be as the first set. So we call the girls as the first set of observations. And how many girls do we have? We have 25. So we call that as n1. Okay. And it says the average weight is 40. So the mean weight, that is the average weight of the first set of observations, is 40. So what does that mean? Indirectly, it means x1 bar is equals to 40. Okay, and then that of 35 boys, it doesn't have to mention 35 because it's already understood out of 60. If I have 25 girls, obviously the remaining has to be boys, so 35. So second set of observation is boys. So how many boys do I have? We have 35. So how many numbers do I have? That is called n1, but over here it's not numbers, over here it's girls. So n1 is 25, n2 is 35. What is the mean of the boys? Is 53. So we have x2 bar is equal to 53, and this is kg. So we have n1, n2, x1 bar, x2 bar. Now they're saying find the mean weight of the entire class. Entire class means, obviously class means it's boys and girls together, so indirectly it means combined. So we have to find the mean weight of the combined distribution. And what's the formula to find the mean weight of the combined distribution? That is this. So we have x bar is equal to n1, that is 21, into x1 bar is equal to 40. We have plus n2 is equal to 35, into we have 53 divided by n1 plus n2. We can write 25 plus 35, or we already know it's 60. If you want, you can write 25 plus 35. Okay, and then 20 into 40 will give me a If you multiply, you get 1000, we get 35 into 53, we get 1855, and then divided by this, we get a 60. And then when I add them, you get it as a 2855 divided by a 60. And then when I divide this in the rough, you can use a calculator, we get 47.583 kg. That's the mean weight. So you do not have to worry about this kind of thing. Now even if this type is given, it doesn't matter. Why? Because you can, if this is given, so you separately go ahead and add them up, okay, and then divided by the number of observation. You call this number of observation as n1. Whatever is the total, you divide it by n1, that will give you x1 bar. Okay, similarly over here also, you add all of them divided by the number of observation, that is n2, and you get x2 bar. Once you get n1 x1 bar, n2 x2 bar, then you can easily apply that in this formula and you can get your average mean. But most of the questions usually will be this type, where they will give you the average weight, they will give you the n1, they will give you n2 and x1 bar, x2 bar, and you just have to apply it correctly and get the answer. So let's go ahead and give you another example. Okay, so let's say we have this one. It says one set of observations, okay, one set of 100 observations. So we have one set and you have 100 observations. So this, how many observations? 100. Obviously that becomes your n1. So n1 is equals to 100 observation. It has the mean 15. Mean is equal to 15. Whose mean? 100 observations mean. So that means x1 bar is equals to 15. Similarly, you have another set. You have how many observations? 150 observations. So n2 is equals to 150. And what's the mean? Mean is equals to 16. So they're saying x2 bar is equals to 16. Okay. So once we have got this, it says find the mean of 250. Means obviously when I add them, it's 250. That means they're saying combined mean. That is what we are supposed to find. So x bar is equals to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. That is equals to n1 is equals to 100 into 15 plus, you can put it inside a bracket, and then you can write 150 into 16 divided by n1 plus n2. If you want, you can write straight away 250, or if you want, you can do it step by step. You get this 100 into 15, you get it as a 1500, plus you get this as 2400 divided by 250. When I add this, you get a 3900 divided by 250. And then you can cancel this. When you divide this, you can use a calculator, you get 15.6. That's the answer of your combined mean. That's how we go ahead and find. Okay, it's not that tough, it's quite simple. You just have to remember the formula. Okay, so let's go ahead and do one more similar type, but let's give you a little variety. Okay, now let's say for example we have this question. Now it says the mean monthly salary paid to all the employees of a company is this. Now the mean monthly salary paid to all the employees means, it's employees means obviously it'll have what? It'll have male employees and it'll have female employees, and this is what? The mean of all the employees means obviously it is the combined mean. So combined mean is equals to rupees 8300, because it says employees. Had it been individually male, then I would have written x1. Had it been female, I've written x2, but this is all employees mean, so we'll have to write it as x bar because it's the combined mean. And it says the mean monthly salary paid to male and female employees was this one. So mean, okay, this is the mean salary of whose? Male and the female respectively. Means for the first it will be the first, for the mean it will be this, and for the female it will be this. So for the first it will be the first value, for the second it will be the second value. So this is what? This is the mean. So we can write x1 bar is equals to 8000, and then we can write what? And then we have x2 bar is equals to 9000. Okay, if you want you can write the rupees, you can write the rupees, or if you want you can write this way. Okay, these are the values. Determine the percentage of males and females. So we have to find the percentage of the male and the female employees. Now if I want to find the percentage, okay, first we need to know how many do we have. Like they are saying whose percentage? I want the percentage of the male and the female. So if I want to find the percentage of the male and the female, I need to know how many male and female employees do we have in this company. So till the time I do not know the number of male and the number of female, we cannot find the percentage. So what we, and over here we do not know how many male and female do we have. So what we say is So we always, if I want to find the percentage, we say let the total number of employees be 100. Okay, why 100? Will tell you the reason. We could have taken 50, we could have taken 20, 30, 40, 50, anything, but we took 100. Why? Because if I take 100, then let's say, for example, if I happen to get the number of male as 20, and since the total is already 100, I can say the percentage is 20%. I do not have to find the percentage separately. So whatever is my answer, that automatically becomes my percentage. Okay, if I get my number of male to be as 30, since the total is 100 employees over here, so the percentage becomes 30. So that's why it becomes my work. It makes my work much more simpler. So that's the reason what we do is we always advise students to go out and make sure that you take the number of employees to be as 100. That's the basic thing. That's the first important thing that you'll have to know about this. Okay, so then out of now number of employees is 100. So now these employees means what? A mixture of male and female employees. So what we say then, let the number of male employees be n. So if I say let the number of male employees be n, oh, definitely therefore number of female employees will be how much? Obviously there are total of 100 employees. Out of that, if I have n employees, means it will be 100 minus n will be the number of female employees. Okay, and since we have considered, okay, the male mean to be as x1, so whatever is for the male, we'll have to take it in terms of 1. So let the number of male employees, that means indirectly n over here indirectly is n1. Why? Because male we have considered as 1, because male's mean salary we took it as 8,000, means we took it as 1. So employees over here is n, so n indirectly is n1. So obviously what is n2 then? N2 is definitely 100 minus n. Okay, so that's so females will took it as 2, so over here female employees 100 minus 1, so n2 is indirectly 100 minus n. So what was the formula for the combined mean? So the combined mean formula was combined mean is equals to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Okay, so I hope you have understood why did I take n to be as n1. Okay, so we have assumed the number of male employees to be as n, and over here, since there are two different we have categorized it as 1 and 2. We have taken the male to be as 1 and the female to be as 2, because we took the monthly salary of the male, we wrote it as x1. So over here male employees is n, so indirectly n will now assume it as n1. Okay, and then since we took the female employees mean salary to be as x2, so the female employees also will have to get as n2, and n2 over here is the 100 minus n. So we've got this much. So now x bar is equals to what is n1? N1 over here is n, so we have n x1 bar is equals to 8,000. We have 8,000 plus we have n2 is equals to 100 minus n, and then we have x2 bar to be as 9,000 divided by n1 plus n2. We have n1 and n2. We can write n1 and n2 like this also, but over here we already know that n1 and n2 means the total male and female employees. Rather than writing n plus 100 minus n, we can take these two total to be as how much? Total to be as 100, because the total number of employees is 100, and n1 and n2 means male and female employees together, so we can write it as 100. Rather than writing n1 as n bracket 100 minus n, we can write it as total as 100, because these two combined together gives me 100. And x bar is already written as A300, so we have A300. This 100 goes up, gets multiplied into 100 is equals to 8,000 n, plus when I open the bracket, what do I get? We get it as yeah, well, oh, rather than this, what we can do is we can make our sum much more simple. What we can do is we can write A300 over here. We can take what? We can take 100 common over here. 100 common. If I take 100 common from here, I will get 80n, plus I'll get 100 minus n, and I'll get 90. Okay, if I take the 100, and then what do I get? 100, and this 100 gets cancelled, then I get A300 is equals to 80n plus 900n minus 90n. Is that okay? I hope that is clear. Okay, and then what do we get it as? Oh, sorry, this is 9,000. Okay, And then what will happen is, now this is a 90 and this will give me how much? We get this to be as 8300 is equals to, this will give me a 9000 minus a 10n, because these two will give me a 10n. And this will go this side, I can bring the 10n this side, and this 8300 will come this side. So 9000 minus 8300. So then if you want, what we can do is, I can get 10n is equal to, I can divide, subtract this, what do I get? 8300 means we get a 700. So n is equal to 700 by 10, and then it goes n is equal to 70. But what is n? N is the number of male employees. So that means therefore number of male employees is equals to 70. Okay, so therefore number of female employees is equals to, it says 100 minus n, so I'll do what? 100 minus 70, that is equals 30. So this is the number of male employees, this is the number of female employees. So directly, since the total is 100, so therefore percentage of male employees is equals to 70%. Now if you want to know how did I get 70, if you want, you can do that also. Number of male employees over the total into 100, and then I get it as, that is how we actually get it as 70%. Now if you do not want to write it directly, if you want to know the entire procedure, this is how we get. So percentage of female employees, that is equals to 30 over 100 into 100, that is equals to 30%. So that's the percentage of the male and the female employee. So this is how we solved. So it was a similar type, okay, similar formula, the same formula, but what happened was, it was a little bit different question where they asked you to find the percentage. And if I want to find the percentage, we have to know the number of male and the female. For that, we'll always assume the total to be as 100, and then we'll assume the male to be as n. The number of female employees becomes the total minus the first, that is 100 minus n, and we get this much. And since we have assumed the male to be as 1, so we take the male to be as again 1. So n, we'll write it as n1, because we want to differentiate between the two observations, n1 and n2. So n becomes n1. So over here n2 is the female. So how many female employees do we have? 100 minus n. So n2 is 100 minus n, and then we go ahead and use this formula. Okay, and then if you feel that no, you want to open the bracket, you want to cross multiply, you don't want to take common, or you found the common part confusing, then you simply open the bracket and just cross multiply, and then you can do that kind of a calculation also. Okay, so that is how we solve this type of question. So that is the entire thing about your mean of combined distribution. That is how we solve questions based on mean of combined distribution. Okay, thank you.